Illusions due to perceptive conflicts are mainly due to a sensory conflict concerning perception of the vertical and the horizontal between the vestibular and the visual system. Cognitive illusions are of interpretation and are associated with the task of mental construction of the environment. The illusion of relative movement is the sensation that your vehicle is moving when in fact it is the vehicle alongside. Being pressed into the seat corresponds with the sensation of starting a climb or performing a level turn. To prevent or overcome spatial disorientation or illusions at night or in IMC, you must establish and maintain a good instrument cross-check and rely entirely on the indications of the flight instruments. Examples of vestibular illusions are: rolling out of a coordinated level turn gives the illusion of descending and turning into the opposite direction. Starting a turn gives the illusion of climbing. Stopping the rotation to recover from a spin gives the impression of spinning in the opposite direction. Linear accelerations give the impression of climbing, and linear decelerations give the impression of descending. Visual illusions often occur as a result of conflict between the vestibular system and the visual system. As motion is detected by the vestibular apparatus, it is sent to the brain, which relates this to experience in the memory store. Pilot action and aircraft response occur, and there's feedback motion, which is again detected by the vestibular apparatus. This ties in with the visual system that sees that a motion has occurred, sends the input to the brain, resulting in pilot action and an aircraft response, and then visual feedback that the aircraft has moved. There are many cognitive illusions which have evolved from studies in psychology which play upon the brain's perception of reality. Although some of these illusions with lines date back to the 19th century, it's still not widely understood and still debated the origin of the actual illusion itself. One thought is that angled lines pointing inwards give the impression that something is closer, and lines which are angled outwards give the impression that it's further away. Here are some illusions which really occur in aviation. In a low contrast environment, for example fading visibility, haze, darkness or snow, fog, the perception of distance and speed is difficult. Objects seem to be further away than in reality, and it's difficult to estimate correct speed and size of approaching objects. The black hole effect is when the pilot is lacking visual cues other than those of the aerodrome, for example at night, over water, jungle or desert. The pilot may believe that he's actually higher and too far away, with the risk of dropping low and landing short. A light that's shining and fading, for example flying into fog, dust or haze, gives the sensation of the light actually moving away. Autokinesis is the apparent movement of a static single light when stared at for a relatively long period of time in the dark. To prevent this phenomenon, look inside for additional references and then outside of the cockpit again using peripheral vision. Flickr vertigo occurs when there are flickering lights, for example anti-collision lights or lights reflected from spinning rotor blades. This can cause spatial disorientation and or nausea when looked at for a long period of time. Strobe lights should be switched off when in cloud. With regard to runway illusions, a wider, larger runway than usual gives the appearance that the aircraft is low, potentially resulting in the risk of a high approach or an early or high round out or overshoot. With a smaller or narrower runway than usual, the pilot may feel that they are greater height than actual, with a tendency to fly a flatter than normal approach and to land short and undershoot. With an upsloping runway, the pilot feels higher than actual, which may cause them to land short. If the area in front of the threshold is descending towards the runway, the approach may be higher than normal, with the risk of a late landing. If no information about the dimension of the runway and condition of terrain underneath the approach is available, make an instrument approach and be aware of the illusionary effects that can be induced. In this image, the runway is sloping. In the top half, the runway is sloping upwards, and the pilot looking down the length of the runway gets the impression that he's higher than normal and may therefore undershoot. If the runway is sloping downwards, the converse may happen and the pilot may overshoot. Similar effects may occur when approaching upsloping or downsloping terrain towards a level runway. In the top image, the terrain is upsloping and the pilot feels higher than normal, therefore may wish to undershoot. With downsloping terrain towards the runway, the pilot may overshoot.